Say you're throwing tennis balls through two slits in the wall. They travel through and they hit the wall in the next room. The general area where they hit is opposite to the slits in the wall because matter tends to travel in the direction it's thrown. Although this is true for these tennis balls, will this stay true for everything? I guess you'll find out as I explain the double slit experiment.
We know what large matter will do, so let's move on to light. Will light act the same way as the tennis balls? Interestingly, light can be both a wave and a particle. But how? Is that even possible? Just see for yourself. When a light bulb is turned on behind the slits, we see a pattern that is different from the balls. It's as if the light has now split up into two waves, each originating from one slit. The light acts as a wave, canceling and multiplying itself at different points of the intersection, creating an interference pattern. Now you might be thinking light has to be a wave. But wait, there's more. We know that the photons interact with each other in a wave-like pattern. So what if we fire the photons one at a time? Then they can't possibly interact with each other. Will they now form the tennis ball pattern? Actually, no. It's like the photons know that there are more of them around, and they still make that same exact interference pattern. It defies everything we know in the macro world.
Let's move one step down into the world of quantum mechanics. Since matter is just made up of atoms, the pattern of fired atoms should be the same as the balls this time around. Please? Nope, we distinguish ourselves again. Even though atoms are matter, weird changes occur at the nano level. From extreme strength to internal perfection, nanoparticles react totally differently than their macro counterparts. When the experiment is performed again with single atoms, it yields the same results as the photons. This breaks the laws of physics that we know at the macro level, since the tennis balls were going straight. Because of this exact reason, scientists performing the experiments were still unconvinced of their results. They set up a detector to measure the amount of particles that went through one of the slits, and 50% went to the top, like they had predicted. But when the pattern on the other wall was analyzed, the atoms returned to the same behavior as the tennis balls. Did the atoms know we were watching them? Like a sixth sense? To test this seemingly ridiculous theory, scientists left the detector in the same position, but snuck over to the switch and turned off the detector to fool the atoms. And, in a twist of events, the atoms returned to their original wave-like pattern.
This, my friends, is the basis of quantum mechanics, a field that probably just baffled you and has intrigued the entire scientific community for decades. As Niels Bohr once said, if quantum mechanics hasn't profoundly shocked you, you haven't understood it yet.